Hey everyone, hello and welcome to today's webinar, Outdoor Drone Inspections, Case Studies and Best Practices from the Field. We're really excited to have you here today. So of course, today is the fourth installment in a six-part series that we've been doing on drone inspections. And we're doing this webinar series in partnership with MFE. We'll tell you more about MFE as the webinar continues, but one thing to note now, our presenter today, Cortland Pank, he is in Canada where he runs a drone inspection services company. We met him through an MFE contact. We'll tell you a lot more about that as we go on. That contact's named Scott Balzer. He's the general manager of MFE in Canada, and he'll be speaking to us later on in the webinar. But today's main speaker is Cortland, and we're really excited to have him here. And there's Cortland right there. He has a lot of experience. I'm going to be introducing him in a moment. I'll tell you all about him when we do the intro. And I'm your moderator today. My name is Zach Dukowitz. I'm the content marketing manager here at Flyability. So important thing about the webinar, we really encourage everyone who's on to ask questions. You don't need to wait until the Q&A at the end to ask questions. You can ask them at any point. You'll see a questions pane on your dashboard from GoToWebinar. Just hop in, ask any questions as we go. We'll be curating your questions. So if you ask a question right now and we can't answer it live in the questions pane, we'll be cutting and pasting it into a document that we'll use for the Q&A that we do with Cortland at the end of the webinar. But please don't be shy, hop in, ask anything you'd like. One other question we get often that we like to answer up front, are we recording this? The answer is yes. We are recording the webinar. The recording will be available tomorrow morning. We'll send it out to everyone so that you can review it. You can share it with whomever you like. Just some agenda items for today. So we're doing the introduction right now. That's just about 5 minutes. The real meat of today's webinar is the presentation from Cortland on outdoor drone inspections. We'll be looking at case studies, best practices. We'll also be doing an overview of things to consider with outdoor inspections, and also common assets and industries that use drones in outdoor inspections. After Cortland's presentation, we'll have a live Q&A. You may notice these webinars from this series have all been 1 hour and 15 minutes instead of typically we used to do 1 hour. That's because we would often go over and we would give the Q&A short shrift. We didn't want to do that. We wanted to give the Q&A enough time. So we're acknowledging that sometimes presentations take about 1 hour and Q&A gets 15 minutes. So please hang out for the Q&A if you'd like. If you're just here for the presentation, obviously, once the hour's up, feel free to leave. But if you want to have your questions answered, please stay. So without further ado, I'm going to go ahead and introduce our headliner, our main speaker today, our only speaker. He has a lot of experience both with drones and with inspections. So Cortland Pank is the Chief Executive and Operations Manager at Osprey Integrity. That's his company. He has a deep history of conducting inspections with a variety of non-destructive testing methods and tools, with an emphasis on visual, external, and corrosion surveys. Cortland is a graduate of Salk College, where he obtained, where he studied aviation technology and obtained an advanced diploma in flight. After doing that, he went on to have a second career in industrial inspections, where he obtained various certifications and became a certified API 510 inspector for pressure vessel inspections and an IRATA level 1 rope access technician, among other certifications. In 2018, Cortland decided to join his knowledge of aviation technology with his knowledge of inspections, and he founded Osprey Integrity, an inspection services company whose mission is to combine compliant aerial inspection with engineering-worthy presentation and reporting. He's also a certified drone pilot in Canada, as you might expect, given the work he does. Where he works in Canada, of course, and he's worked as a corporate pilot, and he brings an extensive knowledge of inspections and piloting to bear on his inspection work with drones. So without further ado, I'm excited to bring Cortland in and kick things off.
Yeah, good morning. Am I being heard okay at the moment?
Yes, sir, we hear you loud and clear.
Perfect. Thanks very much for the introduction, Zach. Appreciate it. Good morning, everyone. So get right into it, I suppose. There's lots of neat stuff to talk about. First off, thanks for having me. I do appreciate it. It's been fun working through the process, putting some of this content together with you guys. And hopefully everybody here gets something out of it and has some questions that we can address there later on as well. So points that we're going to cover, basically just the good old overview on outdoor inspections and how it's a little bit different from the inside and internal aspect. We'll cover different assets and industries. I think we've got 4 or 5 case studies for you today. There are tons that we could talk about. And of course, we're all willing to talk about those and capabilities here at some point. And then just some best practices, things that we're doing out there in the field to make sure that we're delivering to expectation when it comes to these inspections. Next slide, please, Scott. Zach. Outdoor inspections overview. Yeah, so I believe we're just looking for what is the outdoor inspection. And the truth is, so when we talk about defining an outdoor versus an indoor or an external versus an internal inspection, really the main piece that's important here is, will the drone, if it flies away, create a hazard to general or manned aviation? That's really how the regulator looks at differentiating this space. So that's just it. We're using a number of different tools, platforms, payloads to get something that a client is after. But the main part is, do we cause risk to general aviation if we have a loss of control? Next slide. Outdoor drone, really the main distinguishing here is that oftentimes these airframes are capable of being operated or maintained with GPS connectivity, where we don't necessarily have that same luxury in some of the indoor environments. That's really the main difference. Of course, we don't need as much consideration for, say, prop guards or protective housings like we see with the flyability products. That's about it. But man, the array is vast on the different types and manufacturers and capabilities of all these different drones. Yeah, just a quick note here that when we're considering a remote video inspection RVI tool, it's important to know that drones aren't the only option that we have. There's different things like pipe crawlers, even just cameras on sticks are all tools that we can be using. And realistically, it's important for us to maintain the client's expectation and their goal. What is the main deliverable that we're after? We can't just necessarily be out there saying that the drone is the tool for everything. So having an awareness of these other tools is critical for us in the inspection world to make sure that we're maintaining that integrity and representing the best choice for the scope of work. Yeah, some of the other methods that we're up against, and I always like to say that it's not necessarily that we are taking work necessarily from one way or the other. We're simply another tool, and oftentimes we can work hand in hand with these other existing technologies like scaffold, ropes, aerial work platforms. That's a sniffer truck, or a snooper truck rather, that we have going on there. And depending on the scope, depending on the deliverable required, the drone might not be the best choice. And sometimes we work really closely with these other technologies. Rope access is a great example. Before a rope team comes in and starts rigging up for a more extensive scope, sometimes we're involved in finding appropriate anchor points and identifying hazards before bringing those crews in. So sometimes there's harmony. Let's carry on there. Yeah, so when we're talking about equipment, I mentioned earlier that there's so many different options. And I'm going to say this a lot through today, but at the end of the day, it comes down to what the expectation on the deliverable is. There's no one tool that solves every single issue. And it's important to ask as many questions as you need to have a clear understanding on what the deliverable needs to be, so that you can start to think about what the right equipment might be. A couple of things that we are going to look for, though, they're obviously, so safety is a big one, endurance being another. the less that we have to come down and do battery swaps or charge and the logistics involved in battery management, that improves our efficiency. As far as your typical visual inspection, usually we'll run with a high quality, a high resolution visual sensor, but then there's a lot to be said for high optical zoom. I'm sure we'll get questions on that at some point, but intrinsically safe drones are few and far between, and the ones that claim to be are not necessarily solving all the concerns or all the needs that we have in inspection. So maintaining a standoff distance, a safe standoff distance, and in Canada it's about 7.5 meters, but being able to collect footage as if we were right there is very dependent on a high optical zoom sensor. The high resolution is just for a little bit more digital zoom. We can zoom in and just kind of play around, have a better look after the fact as well. All kinds of other sensors as well. So it's not just on the visual side. We can talk about corona, infrared, LiDAR, gas detection, a different band in the infrared. So it just, again, all comes back to talking to that client, making sure that we have a clear understanding of what it is they're after from the drone inspection. This is pretty common across drone technology in general. What we're seeing is, of course, mainly the reduced downtime. And that is, of course, driving a lot of the economic savings in the right applications. It's, there are some where it still is more viable to use ropes depending on what's needed. But yeah, reducing downtime is a huge benefit of using this type of technology. And of course, we're removing people from the line of fire in some of these environments. And another thing, of course, over the last couple of years, or the last year plus, has been the discussion with Corona and trying to limit people on site. So that's another thing that we have in our back pocket for drone technology, is that we don't need the 3, 4, or 5 person crews necessarily anymore, depending on a scope. We can reduce the amount of people on site, which is leading to just a safer environment in general at present. So those are the 3 big bullets. Right here, so like Zach said, I'm not operating in the States a whole lot right now. We have the capability, but I'm not well versed in the regs. So Zach's going to come in and talk a little bit about the regs in the States.
Hey, thanks, Cortland. And I'm only hopping in for about 30 seconds. Cortland's going to go deeply into the Canadian regulations, and there is quite a lot of overlap between the Part 107 rules in the US, which oversee commercial drone operations, and the rules in Canada that oversee commercial operations there. I just wanted to mention, sort of introduce the idea of regulatory considerations here in the US. There is a knowledge test you have to take. It's called the Part 107 test because it pertains to the Part 107 rules that oversee commercial operations. And like in many other countries, it's a fairly involved test, and there aren't a lot of good resources out there. When you go to the FAA website or when you're looking for free resources, it's become common that people take paid courses. I work for a company called UAV Coach, so I'm here to do a shameless plug. They make a product called Drone Pilot Ground School. It's an in-depth test prep course. If you're looking for support, Drone Pilot Ground School is one option. There's other options out there. I know our presenter from the last few weeks, Nick Harwood, he has a partnership with Dart Drones. So obviously Drone Pilot Ground School is just one option among many. But this is all to say that if you are trying to get your pilots ready for the Part 107 test in the US, there is support out there and it is reputable and good. I think it can often be difficult to navigate those decisions when you're just getting started. You see that there's a whole plethora of options. If you're looking for advice, my email, along as the emails of several other team members involved in this presentation, will be available on the Q&A slide. So if you're looking for how do I get ready, either in Canada or in the US or elsewhere, to become a certified commercial pilot, those are experiences and questions that we've helped people answer. So see us all as resources. Feel free to reach out to us. That's all I'm going to say about the US and Part 107 rules. It's really high level for me. Cortland's going to go more into the details now in Canada. So thanks, Cortland.
Yeah, you bet. Thanks for hopping in. So getting into what I consider probably to be one of the more important parts of this webinar is getting at least a high level understanding of what regulations are in place in Canada. There are lots of them. I've selected some that are more important to be aware of right away. And then as we kind of work more in this environment, or you end up providing services in this arena, you'll learn more about some of the more finicky ones that exist there too. But starting with the definition, basically a small remotely piloted aircraft in Canada is defined as something that has a maximum takeoff weight of at least 250 grams, but not more than 25 kilograms. So what Canada did is they created this Part 9 of the Canadian Aviation Regulations, usually just called the CARS, and they defined a set of rules for that weight class that that's it. Those are the canned rules for those types of drones. Anything that falls outside of those, if it's under 250 grams, you're only subjected to one of the Canadian Aviation Regulations, and it paraphrases as, don't be an idiot with your drone. Don't cause any kind of hazard to aviation or people. That's the rule. And then if you're over 25 kilograms, you're getting into a little bit more specialized applications. You're not just going to be able to go and fly one of those because there are no regulations. It's more in depth, something called a SFOC, or a Special Flight Ops Certificate. But we'll get into that a little bit. One other thing to keep in mind is that these cars are derived in part from the Aeronautics Act of Canada. And then the other things that we're considering in doing commercial inspections are the Privacy Act. So I'm thinking more along the lines of residential and commercial buildings, for an example. That's where that one really comes in. And then bylaws. So all of these things need to be adhered, and the bylaws might even be the trickiest part. Anyway, let's carry on. Okay, very good. So these are the list of the kind of the more prominent aviation regs in Canada that mean something to us. First off, we don't have to spend a whole lot of time on this section, but 901.02, any drone that falls within that weight category needs to be registered with Transport Canada. It's a really easy process. They've made it pretty dummy proof. It's I think it's $5 a drone to register. They send you a certificate of registration, and that's part of your required documentation for flying these things. Next up, Canadian regs right now, the Section 9, only covers visual line of sight operations. As far as beyond visible line of sight goes, we know in Canada there's a lot of buzz. The States are about 2 to 3 years ahead of us here in Canada as far as beyond visible line of sight ops go. But in Canada, we're kind of still in that infancy stage. They're doing, proof of concepts. They're doing controlled, basically experiments, for lack of a better term, in safe environments. The foremost range just down by Lethbridge is one of the certified ranges here in Canada where we're doing controlled beyond visible line of sight testing. That's kind of spins into visual observers. It's really interesting. I had Transport Canada explain this to me, the need for a visual observer, because if we think about something like roofing inspections for insurance purposes, that's really simple flying. We're talking, 20 meters up above the ground tops. The drone's never maybe more than, say, 50 meters away from you. Do we need a visual observer for that? So when we ended up talking this a couple of years ago to Transport Canada, they said, consider it like this. Think of it like driving your car. So you're driving your car, and then every so often you will check all of your mirrors, and then you look outside again. And if we think about flying a drone in that same way, you have to have eyes on the drone, or somebody does, of your crew. And then every so often you can check your mirrors, so to speak, which is have a look at your flight control, make sure that batteries are good, signals are good, voltages are fine, maintain some situational awareness, and then go back to looking at the drone. So that's kind of how they distinguish that. It's not that you have to have your eyes glued on the thing at all times, just for what it's worth. Procedures, that's an in-depth kind of section. It lays out the fact that we need to have normal procedures and emergency procedures defined for any kind of external operation. There are all kinds of templates out there for those of you that are doing this type of work or want to do this type of work and want to develop some of these things. The templates are everywhere. The apps are numerous. You can go in the App Store and find things to help guide your procedure generation, but they do need to exist. And in Canada, when we go for an advanced, I guess I'll get down to that in a second there, so I'll hold that thought. So I'll circle back around to that. Site survey, this is basically our desktop planning. It could be tied in with your field level hazard assessment. We ended up at Osprey, we ended up combining the two. We ended up coining something called an ARA, or an airside risk assessment. And it's a blend of both aviation and your typical industrial hazards. We've got that on a tablet. It's a 4-page document that includes a site survey that is Transport Canada compliant. And usually that includes a map, aviation band frequencies for communication, distance to relevant airports, aerodromes, heliports, all that kind of stuff. So that's an important one. If somebody were to show up, I'll talk about enforcement in a minute, but if somebody were to show up and ask you, the site survey is probably the first thing they're going to ask for on site. 90147, operations at or in the vicinity of aerodrome, airport, and heliport. This one's neat. I'm going to leave that for now because I've got a slide coming up where I can dive into that a little bit more. It basically boils down to that if you are, regardless of the airspace designation, if you're within a certain proximity to one of these places, you need to hold a certain certificate. Anyway, getting down into basic and advanced ops, high level here, basically the takeaway here is that there are two different distinguations or two different levels of certification in Canada, basic and advanced. Basic is just that, it's fairly basic. It's a 50-question test. There is no practical component. And you are only allowed to fly in Class G or uncontrolled airspace and within all the other bylaws, because a lot of the parks and all that good stuff fall into that basic environment, but then you have the bylaw. So always keeping that in the back of your mind. Advanced operations opens up pretty much the rest of the airspace, depending on how much documentation you want to do. Usually involves conversation with NAV Canada for authorizations in different airspace. And actually, that goes right into the next bullet point of operations in controlled airspace. And it's just that. So NAV Canada is the governing agency in Canada, and to fly a drone system in these environments that, like we defined earlier, you need to go through an application process with NAV Canada. They're pretty good at getting things turned around. It can be anywhere from, say, 2 to 24-hour turnaround time, depending on their workload and what you're asking for. So that's that kind of wraps up the real important ones. Like I said, we could go really deep into just about every one of those bullet points and break it down. But if you were going to go and try to find like a starting block for doing compliant operations outside, this list right here is probably the most important list to get you going. Thanks, Zach. Right, this is basically just what happens if you are working outside of the regs. Not that we want to be going that direction, but sometimes things do happen. It's a learning and evolving world right now out there. So anyway, things do happen. There are horror stories out there. If you're a corporation operating outside of the regs, and right now Transport Canada can stop us, the RCMP, the local police forces, conservation officers are empowered to do it, peace officers. There's a growing list. Have we been stopped and pulled over for a document check yet? No, but I have heard and know people that have had people show up and ask for all these documents. And if we're found outside of that, basically what it comes down to is that there are fines and they can stack them. So you're in this violation, great. That's, if you're a corporation, that's $5 grand. If you go over and you do this, that's another $1,000 bucks. There's a story out of Churchill years ago now, but the fine ended up being $35,000. Very, very risky operation near the airport, almost hit a helicopter, endangered some people. Long story short, they do enforce these, but you won't see a lot of people out there. So take it for what it's worth. Cool. Airspace. So we talked about basic versus advanced and uncontrolled versus controlled airspace. This is just basically a snip from an aviation chart that we'll use as part of planning. There are tools online that you can go and look and try to find if you need advanced or need basic. And they've tried to sum it up. The NRC, the National Research Council, has put out a pretty good link, a bit of a web tool that helps us identify what's required in what areas, but it's not perfect. And these charts, if you can learn to read these charts, you'll never get it wrong, and you're not at the risk of somebody else telling you that it's safe or not. I put this one in here because it's the oil sands up in northern Alberta. And basically in the bottom left corner, you can see a rectangle, a dashed rectangle on that bottom left side, and that's Syncrude. That's Mildred Lake facility. And that dashed line actually is a control zone for the airport that they have at Mildred Lake. So operating drones at Syncrude actually requires a NAV Canada authorization. So I put this in there because there's a bit of lack of awareness with respect to, oh, well, we're at our industrial site. This is our environment. This is our land. That's fine. It's your land. Transport Canada maintains the rights to all of the airspace, and it's kind of that gray area. It's a funny world. It depends on the guy that shows up to ask you about what you're doing. Some of them can throw the book at you. Some of them will kind of say, well, you know what, next time, just so you know, you don't own the airspace, this is our airspace, so on and so forth. So I put this on there so that there's a bit of an awareness to make sure that you know where you're taking off from, because as soon as you put the drone in the air, it's not your environment anymore. It belongs to Transport and Nav Canada. Funny story on that though, quick aside. You can't really, without a lot of paperwork, take off or land within national or provincial parks. That said, if you can find the border and take off just outside of the park, you can fly in the park all day long, because again, Parks doesn't own the airspace, Transport does. Just a fun little aside. We'll go on to the next slide there, please. Oh, there we go. Perfect. So I talked about that car that was talking about operations within vicinities of airports, aerodromes, and heliports. So I put this snip in here, again, from the same type of chart. This is down by Redwater, kind of close to Edmonton. And we're in uncontrolled airspace here, which is great. So a lot of people will look at this environment and say, well, it's uncontrolled airspace. I only need a basic certificate until you're within that dashed line of that heliport. So that's a 1 nautical mile radius that's set around that heliport. So to operate at the facilities like who's there, Interpipeline and Pembina, sitting there at that heliport, you would need to be an advanced operator, technically. Again, not a whole lot of people out enforcing this, but we're doing the best we can to generate that awareness, and so on and so forth. So let's do that. Yeah, basically, is Scott jumping in here, Zach?
No, Scott will be joining at the very end. So this
Okay,
is just an overview. One other thing to consider when we talk about really drone operations in general, just that you're going to want to look at pilot proficiency.
perfect, thanks. Do we need anything else there? Probably not. You mentioned that there are a bunch of resources online and in person. Self-training is actually a very good bullet point there. Just because you go out and get training once doesn't mean that you're up to speed. So trained, certified, and competent, I believe, are the 3 buzzwords that we like to use. And that competent part has a lot to do with the self-training. Next slide, please, buddy. Thanks. So what kind of pilot do you need? We've talked a little bit about this now with respect to the airspace. Um, and this is really, I like this slide a lot. Are we just getting drone data, or do we want to have the inspection expertise plus drone data? So it comes back, I mentioned that we would say this a lot, that we you need to know what the scope is and what the expected deliverable is. So that drives that a lot. If we're just getting photos to hand off or video to hand off to a client's inspection or engineering team, you don't really need too much more than a certified drone pilot. I could talk to you all day about why you probably still want to have that inspector involved or somebody with some inspection experience, but that's probably a whole nother webinar. Um, the other side here is inspection expertise plus the drone data. And I like to use the analogy of if you fall down and hurt your ankle, you go for an x-ray. That x-ray technician, if your ankle's broken, can probably still tell you that you have a broken ankle. They can look at that radiograph and say, yep, it doesn't look good. But that radiograph still goes to the radiologist to be examined for a formal diagnosis. And this is the way I look at drones versus drones plus inspectors. Um, the drone pilot is the x-ray tech, and the radiologist is the drone uh, inspection combo. On to the next one, please. Cool. Just some general assets and industries. Can probably buzz through this pretty quickly. Super common ones, anything vertical, tough to get up to up high is probably well suited to a drone-based inspection depending on the scope of work. So flare stacks, chimneys, columns, cell towers, wind turbines, bridges, big infrastructure, tall buildings, all well suited to this stuff. Also transmission and distribution systems that I missed on there. Anyway, next one, please. So something that we see a little bit less on the external side, but still relevant, are going to be something a little bit lower. So we don't see the immediate return on investment or the as profound as a vertical asset, but tanks, spheres, furnaces, boilers, heat recovery, steam gens, all kinds of different equipment can benefit, again, depending on what the scope of work is. Why do we want that data? And is it the best tool? Is the drone imagery the best tool for what you're trying to do with that data? Next slide, please. Less common, but still being done. Actually, the Ilios is definitely really well suited to this type of work, but there are external applications as well. But we're seeing, work in kilns or above and around, I should say. Ducting, pipe racks, pressure release valves are really interesting to me, going up and making sure that everything is integral on those. And I like bringing up a point on the PSV side of things. And it actually goes back to our last slide about drone pilot versus pilot plus inspector. The code, the construction code for PSVs, it might not look broken, but it could be out of compliance. And it's just a very specific way on either the diameters increase or decrease at the inlet and outlet of a PSV. It wouldn't look broken, but it could be very dangerous. So I like bringing that up as a, hey, you should work with an inspector type of bullet point. Yeah, and then we're not necessarily tied to really industrial type environments. These installations on forest roads are getting regular inspections as well. And we're seeing a lot of benefit from using drone tech in that environment. Let's do it. Okay, right. So we're not necessarily just doing inspections for the purpose of asset integrity. It can be for safety. It can be for general updates, shareholder kind of up to speedness. So things, drop hazards after big turnarounds, big projects. You've got 1,000 contractors on site doing major overhauls and they get out of there in a hurry. So going for a flight after a major project, identifying, the pin bars or the pipe wrenches, the box of electrodes that's left on a beam, those types of things. So it's yeah, and the tie-in points for rope access I mentioned earlier for kind of a harmony with rope access rather than a clash. Next slide, please. Industry-wise, just a really quick list here. We're definitely seeing a lot of traction in oil and gas, the power gen, refinement, infrastructure in general. We're seeing definitely a lot of adoption in forestry, more so on the remote sensing side versus inspection. But like I mentioned there in the last slide, some of those installations on the temporary forest roads are gaining some traction. There's a real benefit for a bunch of reasons. But next slide, please. Get into a few case studies here. These are personal from our experience. Just a few. Like I said before, there are lots that we can pull from. These are just kind of a different array to show some of the different capabilities. And I'd be happy to take questions, but I will go through these fairly quickly. And if anybody's got direct questions on them, be sure to follow up. So this was at a cement plant here in Alberta. We were brought in. They had basically a flue gas stack that hadn't been used in forever, specifically the upper half of the platforms and the ladder assembly. This is just one photo that we captured during that inspection. They were looking to see if it was safe for people to climb up on these things. Did we see anything breaking away? Was anything giving out? And they were getting ready for some work up at the tip of that chimney. So just one photo showing that we can identify short bolting as a concern. A bunch of other photos from this inspection. There were some where these brackets were peeling away from the concrete. I just find this one in particular to be nice to look at, just because we can basically count that there's 2.5, 3 threads in that nut that are available. So, the alternative for this was a man basket. And basically to do that, they were talking about a crane. So, the numbers that I've got there on the side, cost reductions of about 80%. That's based on me roughing out the cost of the crane and then the amount of time to bring that crane in, set up, get up there and do their thing. So anyway, some rough numbers, a neat use case. Next slide, please. We'll get a few bullet points on it. So versus the crane, of course, a very small on-site footprint. We're pretty non-invasive. So as far as other daily operations, it's a really big plus to not have a ton of site clutter. We don't have people hanging from a basket. They actually tried rope access on this previously, and the guy didn't like it. He declined it for unsafe work. So anyway, that gives you a bit of an idea. Yeah, that's true. We did infrared application on that as well, looking for areas of spalling. Infrared's interesting. So we can visually see spalling, but with infrared, we're able to kind of see, is that spalling beyond? Is it going beyond where it's visible? Can we expect a bunch more to give out in the near future? Next slide, please. This one here, the column inspections. This was neat. We were brought in. That was November last year on this. It was a general API 510 external inspection, trying to see if we could identify things that were previously identified through the boots on the ground method. And the outcome was quite promising. We were also on this one, they were interested to see, could we identify areas of risk for corrosion under insulation with the clad? Could we, between either a visual and an infrared application, look at this thing and say, yeah, I think that you should strip there. Nope, things look pretty promising. We're confident that you don't have CUI issues. Let's go to the next slide, please, and see what we've got for bullets. Yeah, so the big promise here is that, of course, all the equipment remained on stream. What's interesting to me there is that we needed to have that 7.5 meter standoff for intrinsic safety and LEL concerns. So we are able to still perform a thorough inspection. And for those of you who are interested, I can share a few photos from this after the fact, just to show what kind of resolution, what kind of detail we're getting out of, specifically on this one, the PSVs up on the top were really interesting. The other thing that we caught on this were some support brackets that were probably fatiguing out a little bit, or maybe under engineered, but they were warping. So we're able to see that the main downcomer, the main outlet piping on this column in particular was giving out a little bit. So yeah, really cool stuff. Actually, it was a really neat one. We did the infrared about a half an hour after dark. So we let it thermally load all day. The sun went down. We can compliantly operate at night. There are some different rules under the Section 9 of the CARS, just as far as lighting, more so than anything. But yeah, really cool proof of concept on that. We were able to identify some at-risk areas for the CUI that we noted visually, and then went back with the infrared and kind of proofed it up, narrowed down some areas that it would be selective stripping of insulation to have a look. Let's go to the next one. Getting away from oil and gas for a minute, wind turbines are a product that's being done really regularly now. The competition, it's kind of interesting. It's either really high optical zoom, high resolution, almost like telescope-based inspection from the ground, or we're talking rope access. As far as the competitors on this, aerial work platforms as well, but these things are getting taller and taller and taller. So I think we're seeing less of that now as these things push 500 feet into the air. Right, so really cool on the wind turbine side. We've got the process down, and I can't say we, I should say the industry. So if you hear me say we, I could be speaking about the industry in general. We can do all three blades on a turbine in about 20 minutes of downtime. It's just a strategic acquisition. The next bullet there is that it can be automated or flown manually. There are some products, some companies out there that have created fantastic automated processes where you go up and you kind of train the drone real quick, and then it will go fly all three blades at once, capture the imagery you need, and then come back down. The manual method can be just as fast, but it's more stress on the pilot. With the review of the data, right now it's being done either through a blade engineer or an AI review, and there are accuracy differences from what I understand in that environment. Of course, the human component, let's say 95 to 99% accuracy on analysis, whereas AI right now is about 80, is what I'm hearing from the industry, 80, 85 at best. And of course, there are cost differences based on the method that you go with. Infrared is being used to identify spar issues, disbondment, gel coat failure. There are different things working there, which is really cool. So anyway, neat application. Let's go on to the next one. This was a hydroelectric project that we did in British Columbia. Really cool, massive scope of work. It was a large spillway. And we collected over 9,500 images with sub-millimeter resolution. This is just one. I wish I could tell you the scale on that, but I didn't have time to go and pull that. But what we did is through a strategic collection of the imagery, including the spillway sidewalls, the headworks, everything, every component, every surface on that spillway, including those not accessible by being boots on the ground in the spillway, were collected through this method. Then all the imagery was reviewed, and an 87 page report was generated with a comprehensive crack map with different values for, we're calling that there basically moderate cracking and minor spalling. So carry on, please. Yeah, kind of hit all of those. We kept a few workers out of the spillway, which is always a good thing. All the imagery is geo-referenced, so when this inspection is repeated, we can collect the same imagery and end up with a trend analysis, which is important for crack mapping. And yeah, when I went back to the chimney there, the infrared application, as far as trying to determine the extent of spalling, a little bit of kind of proof of concept work being done to identify areas that may have water trapped underneath or behind the concrete as well. That's infancy, but yeah, let's carry on. This is a cool one. I love this use case. This photo is from the Flyability Helios 2. We identified this area of compromised insulation, refrac, on the inside of a heat medium heater at a oil and gas plant. And what was really neat about this one is that, I mean, we're 185 feet up inside that piece of equipment. So we limited the scaffold build entirely, saving a few days. That image was taken, of course, of many. But what was really neat, and I like this one a lot because we identified this internally. We're like, okay, something's going on. And having the capability, we'll go to the next slide, please, Zach. Having the capability to immediately follow up with external equipment, not, hey, we found this, we think you should follow it up. It's like, hey, that looks weird. Let's go have a look right now. So we went up immediately with the Matrice 210 with a couple payloads on it, and we were able to identify that this manway on the top probably had some water freeze thaw issues. I don't know what else would cause that to deform the way that it has. But once again, this is one photo. We zoomed in more, counted threads. We're able to identify how many had backed off, and we found the root cause of what was going on, and we did that within half an hour of identifying the deficiency on the internal. So they go hand in hand, and that'll take us into our next slide here. So external drone inspections is that, maybe they're not versus. They can be extremely complementary to one another. So using an internal tool like Helios and being able to, just like that last use case, being able to compliantly follow up. And for what it's worth, that external photo was taken at that location at the heliport. So if we had not been advanced operators and had that awareness, we wouldn't have, well, A, been compliant, or B, being able to pull it off. So there is something to be said for encouraging your crews or the department that you're making, or even yourself, to move towards advanced certification. It's just a higher level of understanding, and it's really cohesive with the internal side of things as well. And yeah, like I said earlier, there's no one tool for everything that you're going to be trying to accomplish. It's important to either have a vast fleet of drones, or to have access in those strategic partnerships in order to pull off some of this work. Let's go to the next slide, please. Get into a few best practices here. Basically, it boils down, in my mind, like this. Basically, there's a lot of desktop planning, historical review, so old reports, our risk analysis and mitigation. So we're doing that JSA and following it up with an ERA or a FLAHA. That kind of ties into the environmental and safety checks. And then we go, we work the plan, and then we make sure that the data is acquired the way that we expected it to on site before we leave. I think we break these down a little bit further now. Yeah, so these are great. Desktop plan, we can do a lot from the desktop now, especially from an external flying point of view. A little bit more difficult on the internal side, where you're trying to visualize design drawings in 3 dimensions and figure out what kind of risks you're getting yourself into. As far as airspace goes, and trying to develop your understanding, it's a little bit easier for us on the external side. What's important, big time important for me, especially when we talk about that deliverable, is defining that datum. So what are we using for zero elevation? What are we using as north? Is it plant north? Is it cardinal north? Are we using a specific manway? Whatever. Those things are defined. The big difference between internal and external at this point is airspace. On the internal side, we're not as concerned. We're not necessarily concerned at all about airspace. So this is a big part, and it comes down to some of those charts rather. Having the right apps or help, the web tools that I mentioned. Or having someone on your team that really does understand this stuff thoroughly. Of course, that's probably the best bet. Get yourself educated on it all. Be realistic with your limitations in that knowledge, and seek consultation and training to increase your knowledge in that space, and it'll become a lot easier going through it a few times. Any authorizations, so I mentioned airspace, so that could be controlled airspace, military airspace, special use airspace, whatever. You can get into it all. There's just a different process, and it can take a lot of time depending on where. So military airspace is a great example. A lot of work has to be done to get operational in military airspace. Cool, so the desktop planning, basically we're scouting safe takeoff and landing location, and brief the impacts on trades. So I think that one belongs a little bit later, but we can talk about it here. Basically, we need to be aware that without safety equipment, there are little parachutes that are being created and strapped on to some of this external equipment so that you can compliantly fly right overhead of people. But this is another Transport Canada kind of nice to know, is that right now they're defining a bystander, they're defining a person or a bystander as somebody not directly involved in your operation. So when we asked Transport about this, the answer that we had was that, well, if you go and you talk to everybody on site, or you're able to inform, bring all those people in on the details of your operation, that they are now briefed. They become part of your operation. They're aware. They know the risks. They know to have their PPE on. And now we can fly over top of them without something like a parachute. Where, just for what it's worth, another industry kind of takeaway here, that's all well and fine until something happens. And this is a true story. Not us, luckily, but a competitor in the industry had a drone fall out of the air for whatever reason. These things happen. We've had our fair share of incidents. It's new tech. We learn from them and move forward. But it's a legal issue now on the side of, well, you shouldn't have been flying over people. Like, why were you flying over those people? And there's nothing clear enough in the regulations to say that, well, those people weren't bystanders. So it's a interesting situation right now with that one, where yes, Transport's saying, yeah, you know what, if you brief them, they come into your scope of work, they're aware of what's going on. Yeah, they're not bystanders anymore. They're up to speed, unless something happens, and then it gets hairy. Just for what it's worth. Let's carry on there, buddy. Thanks. This is just good inspection practice. We, anytime you're going to be going to do an inspection, and I assume we have some inspectors here in the webinar, we review the historical data. We look at the last report that happened before we go out. Same practice with the drone, especially on the external, internal too. It's all important in inspection work. But I'm going to tie it back to really being clear on setting those origins, those datums, because we're going to be creating a product that 3, 4, 5, 10 years from now, somebody is going to go refly or re-inspect, and we need to communicate clearly our situational awareness for altitudes, the way the camera is facing, camera pitch, those types of things. Let's carry on, please. Yeah, this is all things. Those are the devil's advocate questions, basically. What could go wrong? What can be done if it does? It ties into the car requirement to have emergency procedures, knowing that if this, then that. Some logic. Battery signal, recovery points, and plan. Part of the site survey, again, going back to these Canadian aviation regs, is to have not only one, but an emergency takeoff and landing location defined on your site survey. Yeah, and can inspection tool or client equipment be damaged? These are usually things that we can address in those early conversations, make sure that the risks as well as the benefits are well communicated. Next slide, please. Yeah, good stuff. Environment and safety checks. I would say that aside from what we're used to in everyday industrial life with respect to safe work permits, JSA, JHA, all that, for the for the flying side, environment-wise, we need to make sure that we are operating within the limits of the drone, the manufacturer-defined limitations, and other than that, wind and temperature, of course, precipitation. Those being the three big ones. And the airspace. So we're going to basically confirm that desktop planning, and yeah, the checklist, again, time back into the cars, just all good stuff, really. If you're developing your process, your standard operating procedures, and you're using the cars, the layout that they have, you're going to be well prepped on all of this stuff. Next slide, please. This is the one that is, you'll only ever screw up once, and then it sticks with you. We need to, like I said, it's tech. These things happen, but we got to fight the complacency. Essentially, fight the complacency to just button it up and go home and worry about the data later. No, you got to take the time on site. To make sure that you have all the footage that you need to provide the deliverable that was expected. And we do that on site. Like I said, you'll only screw it up once. Lucky for us, it was in a mapping mission, not in an inspection mission, but it sticks with you, and it aggravates you, really. Next slide, please. Cool. I think that's kind of it for me here for a little bit. And Zach, all you, man.
Awesome, thanks, Cortland. I'm just going to walk us briefly through a few things, and then we'll go to the Q&A. So one thing, obviously what's up on this slide, we are doing today the 4th webinar in a series of 6, as I mentioned in the intro. We have 2 more webinars upcoming in the series. You'll see those at the bottom of this screen. One is on how to manage data, very relevant to what Cortland was just talking about in the last slide, how to manage data for all stakeholders involved. So we'll dive a lot deeper into best practices around data management. That's going to be on April 15th. And then the final webinar in the series is about data localization, which is really, if you see a defect in footage that you've collected remotely using a drone, how do you know where it is? If you want to go back and actually fix the defect, you need to know exactly where it is in an asset. That could be tricky if you're dealing with a sewer system, a lot of scenarios where the more precise you can be, the happier everyone involved will be, especially if you have maintenance workers who might have to dig down to try to access the location to do work. So that's the last webinar, the importance of data localization. We'll be talking about our new software, Inspector 3.0, that's going to be launched in a few weeks. So that'll sort of be, I'm just teasing that a little bit right now. We're excited to share that with you guys. One other thing to mention, as I said at the beginning, we're doing this series in partnership with MFE. MFE has locations all over North America, as you can see on this map. Obviously today, we're getting a lot of help from MFE in Canada. And with that being said, I'm going to invite Scott to hop on. I mentioned Scott at the beginning. He's the one who introduced us to Cortland. We're grateful to him. We're grateful to Cortland for taking the time to be here today and doing this presentation, sharing from his expertise. I know Scott had a few words he wanted to share about what MFE might be able to provide to those in his area. So Scott, if you want to join us.
Hey, Zach, thanks very much. I just want to take a moment and kind of summarize the theme that we really heard loud and clear today. Practice, 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 and prepare. Know the risks, know the mission, develop a successful mission, deliver it to your client, and continue driving the industry forward. A few things that I need to do right out of the gate. I need to say thank you, Zach. I really appreciate your help in putting the webinar together today. Cortland, thank you for doing such a great job on summarizing all of the information from your experience and expertise, your knowledge of the industry, your knowledge of the rules, your knowledge of the regulations. It's critical for all of us. I know Johan was here from Flyability. Thank you, Johan. A pleasure to see you. And thank you for all of your support as well. As Zach mentioned, MFE in North America, we're a major partner of Flyability. What we bring to the table for you, the end user, is the sales, the service, the repair, training offerings to the industry, supporting the business of yours by offering best-in-class delivery of drone-related products. I'll tell you straight up, I've heard it many times, the right service provider is critical, and it's critical at all steps in the delivery of the program. Feel free to reach out to me at any time. I'll gladly steer you to the best solution. Look forward to being of service. It's been really exciting to be a part of today's presentation. And most importantly, thank you all for attending. Look forward to being a part of answering the questions that you've got. Zach, I'll turn everything back to you. Thanks again, everybody, for being here.
Thanks so much, Scott. So just one more slide and then we'll go into the Q&A. Just a quick note along similar lines as what Scott was just talking about. If you have drone technology or training needs, you can go to Scott if you're in his area. There are resellers of flyability products throughout the world and also of external drones throughout the world. So if you have any kind of drone question, drone need, you can reach out to Scott or you can reach out to me. I'm gonna have a list of emails on the very next slide that these are all folks if you have drone technology questions or training. But if you have drone inspection services needs in Canada, Cortland might be the best option for you. So we just wanted to make sure that you have his email and you know if you'd like to reach out to him, if you're looking for drone inspection services in Canada, Cortland is here with Osprey Integrity, and he would be happy to work with you. So Cortland, do you have anything to add before we dive into the Q&A?
Yeah, and it's just basically on the last slide here. Feel free to reach out even if you've got your own drone inspection program or you're doing it internally. Like Scott said, massive advocate for everybody doing it to the best as we can to represent the industry. The more that you guys succeed in your operations, the better it looks for me and my business. The more I succeed, the better it looks for what you guys are doing as well. So it's just collective, everybody moving in the same direction. So I'm not going to be cagey about it. I'm happy to share any and all of the experience that we've gained over the last few years. So yeah, don't look at it as just a service opportunity. Feel free to just call me with any questions.
Excellent. Thanks so much, Cortland. And yeah, so that all being said, and Cortland, thanks again for the presentation. It was excellent. So let's go ahead and dive into the Q&A. Cortland, I've got a question for you. This is from David, who's asking, can drones detect the depth of pitting and corrosion that might be seen in footage?
Right now, the answer it's no. Of course, there's a lot of interest in it. There are some technologies being played with, but it's probably a question better suited to the R&D, the tech type environments, flyability being probably a prime example of who you could ask about that. But as far as an off-the-shelf, something for us to go purchase and put into service use, there's nothing that is doing the trick yet for depthing of these things. We can shadow and gain a general understanding. We can definitely determine extent or scale, if you will. So, well, minor pitting versus more aggressive pitting, but we can't define what those values are yet.
Yeah, and that was the only thing I would add is you already touched on this with shadowing. With the Helios too, if you're flying indoors and you see pitting or corrosion, there is an oblique lighting feature that we made to mimic an inspector standing there with a flashlight so that they can move the flashlight around and try to see depth and really see the three-dimensionality. So we have this oblique lighting feature that allows you to do that remotely, but of course, as you said, we're not getting into measurements or specifics. It really just allows you to sort of see better than if you were just lighting directly onto the surface.
It's great for weld profiling as well.
Oh, good. Well, that's something I didn't know, so thank you. We had someone, I think Philip just asked about spalling detection with infrared. Is that something that you could touch on?
Yeah, so essentially the way it works, or at a very base level, this structure will thermally load. And if there is a discontinuity, a break in that structure, what we see is the thinner areas are more saturated with thermal load. So they appear hotter, at least in that environment. So what we see, they also cool more readily. So depending when we fly, it's a massive topic for infrared flying is when are we flying? What's the thermal load like? So with spalling, we're basically looking visually we'll see it. And then what we try to do with the infrared is to say, okay, there's our visual side. And now where it's not necessarily visually spalled at that time, but we can see a different thermal pattern associated towards the outer reaches, if you will, of the visually spalled area, we can reasonably assume that those areas are going to be subject to spalling in the near future.
Excellent. Thanks so much, Cortland. Getting into software, we have a question from Ricardo who's asking about the use of digital twins. Have you used digital twins for any of your inspection work?
Yeah, it's an interesting space. Had a really cool conversation yesterday. There are some products that are getting close on the digital twin side. As far as a deliverable, there's nothing that I've been blown away with yet, because we come from an environment where we need to see a lot of the asset information, all of that static data that is involved with these assets. And a lot of the softwares that are doing digital twin representation and presentation of these inspections are not allowing enough flexibility yet to include all of those things that I want to see as an API 510, or I would be comfortable handing over to an engineering department. So I'd say that we're getting close, but there's nothing that I stand behind fully yet.
Sure, that makes sense. Related question, follow-up question actually from Ricardo as well. Do you have any opinions about software that use machine learning and AI for inspections? Have you encountered, I think it sounds like he's just sort of curious about what you've seen and what seems to work.
Yeah, so really love the idea. I know that it's going to be going in that direction. It has to, it's the next thing. What I like to bring up for machine learning and AI as a deliverable is that so many of these engineering packages from an inspection standpoint, they vary vastly. So it could be a heat recovery steam generator made by X company. You go over and you see a heat recovery steam generator created by Y company, and they can do the same things, but the design and the construction can be very different. So when it comes time to machine learner AI in that environment, I think it gets a little convoluted. I'm not an AI expert, but this is what I understand about the variety. AI depends on a really solid training base. And when we have all that variety, it gets convoluted. Somebody can correct me if I'm wrong, but that's the way that I understand it right now. But it will happen in time. I think we'll see it in more simple applications like insulation deficiencies, external above ground storage tanks that are insulated come to mind. Well, we can identify that the insulation is broken there, or it's gapped over there, or a strap is missing somewhere. Those are the things that I see in the immediate future for machine learning AI. I mentioned wind turbines as well, so it's it's coming. I know I'm saying that a lot, but it's kind of just where the industry is. We're seeing a lot of progression into the digital representation and analysis of inspection data.
Sure, yeah, and it's pretty remarkable when you think about how far we've come in the last, say, 5 years with the hardware, the capabilities of just the Zoom, features, or being able to fly indoors, but we still have a long ways to go with, how do we process thousands of hours of data, for instance? How do we do it efficiently? All those things are in process. So I think we're in an exciting time, but it's not a perfect plug and play for everything you might want just yet, right?
For sure.
Question about insurance. So David is asking, you had that story, Cortland, about the drone falling from the sky. David's asking about liability insurance for drones.
For sure.
Do you, so there's the insurance for your drone, but then there's the insurance for what the drone might do if it falls. So David's just wondering about liability insurance. Is it a problem if it causes damage on site? Whose liability is that kind of thing?
Yeah, 100%. So we're seeing, from a commercial standpoint, you need to have the commercial general insurance as a blanket, that liability insurance. Of course, auto and drone is absolutely there. So drone insurance exists. There are a number of carriers for it. If anybody's searching in Canada, I highly recommend Hub International. They are the most competitive drone insurance agency out there. Really easy to work with. Fantastic, really quick. And then from the inspection standpoint, we'll carry errors and emissions insurance as well. So it's kind of this full suite. And like you said, yeah, the drone coverage is, sorry, Zach, you got a question there?
Oh, no, I don't.
Okay.
Sorry.
Yeah, no worries. Yeah, it's if the drone falls out of the sky, the comprehensive covers or the hull coverage is where you're going to get the replacement on your drone. But we can carry whatever number of liability. We carry blanket of 5 million liability on any drone activity, and then we can bump it up to 10 or 25, depending on how stringent a client wants to be with it.
Got it. Thanks so much. So definitely something that you want to be thinking about, and I think David's right to be concerned.
Yeah, it's definitely for site access. A lot of the time it is a prerequisite. It's not anymore under Transport Canada. They used to mandate or regulate and say you must be insured. They've gotten rid of that. It's all up to our own case. But to operate in those commercial environments, a lot of time that site access is based on carrying enough insurance to make sure everybody's covered.
Excellent. Thank you. We have some questions about sensors for drones, and so one is about a sensor that I think was mentioned much earlier in the presentation from Sanad about the corona sensors, and then
Sure.
another is from Tushar, who's asking about whether there are ultrasonic thickness gauges that you can add to a drone. So if you could address those two, or any other
Sure.
sort of unique sensors that you've encountered.
You bet. I don't know what they'd like to know about the corona sensor, but essentially it's a UV blind sensor. They put a visual camera and they put a UV blind or a solar blind infrared camera next to it, essentially. So what we're seeing when we get any activity on that sensor, it has to do with electrical discharge. And the visual just helps us overlay the discharge into the visual environment, so we can say, well, that connection there, or that insulator shot, or whatever. That's as far as I can go with that one. They exist. It's a dual system, and they're UV or solar blind, so that we're only seeing electrical discharge. They're being carried on things like DJI M600s or Bobby Watts, the innovations. They're being hung on the Prism and the MFD 3000, stuff like that. The other one, ultrasonic sensors. So love this topic. I'm a UT2 here in Canada. That was how I got into inspection to start. I was a corrosion survey guy. I progressed that into the visual inspection world. So I am picky about the UT side, and for a long time, there are a few packages out there that you can go and you can get a UT probe that you can strap onto an existing drone, but they're a bit wonky. I don't like them. I don't think that they're doing a good job of getting data that I would stand behind, either as a UT2 technician or as an API 510 reviewing that data. There are two companies that I'm interested in. One is Volero. They're over in Europe there somewhere. They've got this really neat tilt rotor assembly, and they're doing all kinds of neat attachments, one of them being ultrasonic thickness. The one that we work closely with at Osprey is a company called Skygauge Robotics. They are out of Toronto area, and they have made a custom drone platform, again, tilt rotor type method, with a DL38 Plus strapped to it with a couplet delivery system and all kinds of neat features. And it's all about that point of contact. So they are coming. Skygauge and Volero both will probably see some action later this year, July, August. And those are the ones that I'm excited about, because they created a drone for the application. They didn't take a UT probe and try to put it on a drone. And that's the big difference there.
Very cool. And again, to your original point, and a point you've made several times about thinking about your data need and then backing into the technology to get it, instead of thinking about a cool drone and then figuring out what it can do.
For sure.
And so I would encourage people, again, if you have questions about sensors, Cortland is a wealth of knowledge, as we've seen. So feel free to reach out to him if you have follow-ups, and to Scott as well. Scott knows quite a lot about RVI technology in general. So really, either one of them are a great resource. I think we have time for just one more question. We have Gary, who's asking about best practices and details for applying both for flying BVLOS or for an SFOC, maybe either or, if you could speak to that.
Yeah, so they're going to be kind of one and the same. Gary, probably encourage you to, Jerry, encourage you to just send me an email if you have specific questions in mind. The SFOC process is lengthy, and for the BVLOS side, there's a document called SORA It was put out by a platform called JARIS, which is, I might get this wrong, but the Joint Authority Rulemaking Unmanned Systems, JARIS, something like that. And they put out this document called SORA, and that has been adopted pretty much globally at this point as the template that is to be followed to apply for a BVLOS SFOC. I can tell you, I do meetings twice a month with the RTM task force in Canada, and we're involved with the beyond visible line of sight conversations and the regulatory progression in that space. And there is no cookie cutter answer. The best option you have is a development with a client who has mutual interest in that technology and the return on investment, and go with it together. Get the approval of that client to go operate on their site or that stretch of 20, 30 kilometers of pipe, and create a playground to mutually explore, because you're going to get denied on the SFOC. They're going to kick back and say, no, we didn't like this. You need to try that. You need to try this now. And it's a moving target. It can be very frustrating. You think that you've got it all set up, you take your 3 weeks to make the tweaks, and then you send it in. They say, actually, we've learned about this now, and we'd like to see more of that. So you're back to the drawing board. So find your dance partner, as I like to say, and go kind of on it together. But feel free to send me an email if you have specifics.
Fantastic, thanks so much. Cortland, one last question from Peter, who's just asking, do you ever fly the Helios 2 outdoors?
Yep, I think there are some neat applications with the Helios outdoors. One thing to keep in mind, it kind of ties into what I said here today, is if you're going to fly it outside, it's got to be registered with Transport Canada, and you're no longer in that internal space. So everything that I talked about external drones today absolutely applies to flying the Helios outdoors. That said, really cool in a pipe rack environment. Really neat application is frozen lines. So traditionally, if a pipe is frozen, thermography is a great tool, but if you can't get up into the pipe rack, you can't get thermography on it. So the answer a lot of time is radiography. Still, radiography, you go and shoot and try to find clogged or frozen lines. But the Helios is a really neat tool for using its thermal capability to do that pattern identification. Hot pipe, cold pipe, you probably have a freeze there. Another one goes back to the safety side after a turnaround. So again, you've got a bunch of trades working in pipe racks, replacing spools, whatever the case is, and everybody peels out of there in a hurry. And sometimes they forget some of their stuff, which become drop hazards. So the Helios, again, up in that pipe rack environment, or just complicated environment in general. Hey, like it doesn't have to be pipe rack, just busy areas are well suited to the Helios for sure.
Excellent, thanks so much. Yeah, I'll mention too, and this is not a use case that Cortland would ever run into in his line of work, but we've seen some public safety applications where after a fire, or even sometimes during a fire that's smoldering, firefighters or police will send the Helios 2 in to see what's happening. And that's sort of an indoor-outdoor scenario where you might be flying a little bit outdoors because the roof has been burned off or something like that. So there's some other, and I don't think you mentioned bridge sort of infrastructure applications just now. It's similar to pipe racks, right? Like you have these complicated but external spaces where you're just trying to get entry and see what's going on. That's another scenario where we've seen the Helios 2 be used outdoors.
Yeah, grout pads a lot of times on those bridges. Yeah, where the steel is coming in contact with the actual concrete structure. Yep.
Yeah. So we've gone over. Cortland, thank you for your generous, the just generosity of time, the time that you've given preparing for this and being here today, answering all of our questions. Really appreciate you. I also want to thank Scott, who introduced us to Cortland and who was here as well. And as Scott said, I want to echo his words. Thank you to everyone who's attended, who joined us today. We're really grateful to you for taking the time to be with us. I think that's going to close us out. Look for an email from me coming out tomorrow with a recording to this webinar. And the last thing, don't forget, this is the beginning of a conversation, not the end. So all these email addresses you see on the screen, email Cortland if you have inspection questions, email Scott if you have technology or training questions, email me or Johan if you have more general questions about the Helios 2 and inspections. Johan there at the bottom, he can help you if you have questions and you want to, let's say, buy an Elios 2 or learn more about it, and you're, anywhere in the world. Johan's probably your best contact. If you're in North America, Scott's probably your best contact. So thanks to everyone who made this happen, and that's going to close it out for today.
Thanks very much. I appreciate all the words there, Zach. It's been fun. Thanks.
Thanks, everyone.